Evening. How are we all? Apologies for being slightly late this evening. We were chasing kittens around the garden. They've got to the point now where they're like determined to get out the door. So every time I kind of open the door to get into the office, they just like pile on me. And yeah, I was like trying to wrestle them through the door as I was trying to get through the door. And ultimately I failed. So we were chasing kittens around the garden. But they're all back in the office now, so we're all good. They also have the zoomies, so you might hear chaos behind me. So, it is Caravella time, and I thought it might be nice, following on from last week, where we were building up some of the hardware aboard the ship, to try building up some new hardware that we haven't seen yet. So if we do the RCS thrusters, then we'll start looking at the actual physical movement of the ship, because right now the movement isn't like properly physicalized. It's more of just a movement component. We're not applying any impulse. So let's do that. Let's actually apply impulse where the RCS hardware is actually located, and start seeing how that sort of affects the handling of the ship. I think that could be quite good fun. So let's do that. And yeah, this is another one of my test maps, which is why it looks weird. I've been bug fixing for the past couple of days. Oh, actually, on that note, so we're in the sort of phase now where we're preparing to get the demo updated. I'm really hoping to get it done by Christmas. 3 of the blockers are now resolved. I just need to sort out this last one. It should be. I think it's probably not even a bug. I just need to make sure it's working properly. And then we've got a bunch of these major ones that I really need to get on top of. And there's a couple of other minor ones that are assigned. Anything that's currently confirmed on the tracker, I'm not going to fix for the demo. So basically, anything that's assigned, hopefully will get fixed for the demo update. And anything that's obviously major or block is holding up the demo update. So we'll get them done. Oh, can you not, AJ? Oh, well, sort that out. Yeah, you should be able to access it. But yeah, so a bunch of stuff I need to go through and fix on there. That aside, there's only 2 critical things really for the VR side of things. I still need to sort out the ability to access the settings menu from within VR within the game. Works fine from the main menu. I just need to make the in-game menu 3D. And also I remembered yesterday that the labels you see out of the window, the name of stars and things, obviously that's a 2D effect, so that doesn't work in VR. So that needs converting to a 3D effect as well. Once those 2 things are done, we should be good for a VR release. Some nice to haves would be arm swing locomotion, if I can find the time to do that, and also seated VR as well. Right now our VR is like standing VR, so it's room scale. I really want to add seated VR as well. So basically you just use the headset as a monitor. You can look around while you're running about. The only complication of that is like being able to target things in VR with the mouse. So we're going to have to have some kind of physicalized mouse cursor. But I'll have a look at that if we get time. I'm definitely doing it at some point, just maybe not for this update. Yeah, I'm eagerly awaiting the frame. I think it's going to be a really, really nice headset. Yes, we can now land on planets, with many a caveat. Something we did on Friday's stream is we managed to fix a bunch of the issues with the landscape, like losing collision after a certain distance. If I just set this back. Actually, no, I'll leave it on 2 players a minute because I want to see how much of the landings I broke. Are we even near a planet? Yeah, you'll do. Just head over there a minute. Yeah, since we changed a bunch of the stuff with the planetary landings and sorted out a bunch of the systems for that, I haven't done another test in multiplayer, so we'll just make sure that that still works. Okay, so we should have a surface teleporter which has spawned. Again, for anyone that hasn't been paying attention lately, the portal is very much a temporary measure. The route down to planets will be via shuttle, but for now we just have this teleporter. So here's the planetary surface, and as you can see, all the grass is black because we're not on one of the procedural planets. Yes, this is Venus. Anything with an atmosphere right now will be spawning foliage. Obviously, when we do Venus properly, it won't have foliage, but for now it does. So the question is, does it work for the client? Sort of. Okay, so the host can see them, but they can't see any terrain. Okay. So I think what's happening there is it's not spawning the terrain on the client side. Obviously from the server side, everything is fine. So that's just something else I need to look at. Hang on, let's go to Earth and we'll find out. So something I do need to do is leave the surface as the client, because otherwise they'll fall through space when the surface disappears. So when we're in range of Earth, the portal should reappear. Yep. Yeah, nothing in space right now is physical, and that will remain the case until we sort out like collisions and things on the sublight side of things. Right now we have no sublight flight as such, so that's why that's not working. Where's Earth gone? It's not where it thought it was. So because we're running it in the editor, the database that stores all the custom systems, like the Sol system, doesn't read very well from within the editor for some reason, which is why you get some weirdness. Right, so there's Earth, and this would be Earth's surface. Looks very similar to Venus's surface because we're just testing. Okay, and then if we go down with the client, yeah, so the client still can't see the surface, but the server can see them, so tweaking to be done there. Luck Dragon, thank you. In Star Trek TOS, the transporter was created as a cost-saving idea because shuttle scenes were more expensive. Indeed, yeah, and I like the fact that we don't have like set and budget restrictions with what we're making, so we can make what makes sense. Transporters as a technology are crazy powerful in universe and highly implausible in terms of the science. So I'm glad that we're using shuttles. Thank you, Zerpanic. Yeah, we've been hard at it. I mean, it's been almost 2 years now since Kickstarter, and yeah, we haven't stopped. We've barely had a day off, so yeah, lots being done. But yeah, so as we demonstrated in Friday's stream, you no longer fall through the planet when you go to a certain distance away, and the terrain will just keep generating forever. So I just fall down. It just my character just gave up and flopped off the hill. Come on, get up. Yeah, something I wanted to test with this actually is in a packaged game, have a client and a host run in completely separate directions, and just make sure that the collision and the foliage spawn keeps up with the player, with both players, both host and client. There's going to be lots of little issues like that where things are going to require work to make it work properly in multiplayer. Yep, just me. We've got a couple of contractors we bring in for bits and pieces, but on a day-to-day basis, it's just me. But yeah, that all seems solid, so that's good. And the client is still workable, so that's good. Right then. Enough of that. Okay, so after the last stream on last Sunday, I went ahead and moved these apart a little bit to start to get an idea for the spacing of them, and I also sorted out where the doors are, because we had like a corridor running through here that we don't actually need, so that's done. I also added the door here, so where the shuttle bay is, we've got our door now into engineering properly. So we've got our staircase which goes all the way up to the top. So then we've got our battery room at the back here, access into the engine pylons, and then through here you've got what will be the science labs once we build them in, and then the cargo lift will be running up and down here, and then the cargo hold is here under the shuttle bay. So I added these wall sections in as well, just to get an idea for just the physical space that we have for storing stuff. It's not a lot, to be honest. In fact, the Caravella is an interesting ship, because as much as it's quite big, it's also too small at the same time, and we're really fighting that space requirement continuously. I think in hindsight we've probably gone a bit heavy in terms of corridor size. I mean, they are kind of overly generous in their width, And we've got some, like, around where the main stairwell is, I think there's a little wasted space here that we probably could have done better, but you know, lesson learned and all. This was meant as an experiment, so that's good. Ah, what's to say? I thought we had a ceiling there somewhere. So what we need to do with this ship then is we need to start building in the RCS hardware in its actual home, and then we need to start, I guess, looking at the physics side of things, and then making sure that our proxy mesh that's actually running the physics, you know, has the proper center of mass and is properly receiving inputs. So what's the best way of doing that? I suppose if we grab, yeah, let's grab the actual proxy for it, and then we'll start having a look. Yeah, this is our second ship that we're making, which we're building as a small test bed for all the new systems. So like the RCS, we needed something that was small, that loaded quickly, and enabled us to prototype all these new systems without having to deploy it on the behemoth that is the Magellan class. It's it just makes for efficient testing, and it gives us a new ship that we can package with our Founders edition of the game when that comes out. Sometime next Christmas, fingers crossed. Okay, so what I want to do, right now we're using a plugin called 6DOF, and that's basically a movement controller where you can apply inputs for the various axes, and it applies those impulses, and it handles things like you know, replication of movement and that sort of thing. And it has a few built-in functions like pointing at a certain vector, and it handles things like mass and the lag you would get from trying to turn an object with mass. So it does a lot of the heavy lifting for the movement side of things, but I want to get rid of it completely and build our own solution for applying impulse directly using RCS thrusters, so that we'll have individual physical pieces of hardware which are applying force to the ship. And of course, if they break, then they're no longer applying force, which means the whole handling model changes. Just simply by losing one RCS thruster, you could like completely lose control of the ship. So we want to, you know, build that simulation into the sublight flight. So the first thing we need to do is just make sure that we can do that with a pawn. I think we can apply physics to pawns if they're simulating physics. Right, so our center of mass is literally right in the middle, and definitely don't want that mesh, so Come on. Right, so the world origin for the center of mass should be right in the middle. If we add a socket, where is that putting it? Yeah, so that's the geometric center, isn't it? Yes, we might need to move the center of mass back a little bit. Obviously, a lot of the mass of the ship is going to be here, and a lot of the front is just empty space. But we'll see how it handles. Thank you. Glad you enjoyed it. Right, where is the tick, tick, tick? Oh, yeah. I try and avoid doing anything on tick, if I can possibly get away with it. I much prefer doing timed functions rather than doing things on tick. I may be wrong in this, but as I understood it, if you're running tick on a blueprint, it's kind of refreshing or assessing the entire blueprint when the tick is running. Whereas if you do a timer, like timer by function, then it's only running that function on a timer instead. So it's more efficient to do it that way. That knowledge might be about 3 or 4 years too old out of date though. Right, yeah, so guess we kind of need something else in space to be able to compare this to. I guess we'll use the shuttle. So we do an impulse of 10. Not quite sure what kind of scale we're going to need for this, power-wise. And let's change our spawn location. So grab him. Where are we? Vessel ID, yep, that one. So we're just changing our spawn point to the bridge to make it easier for testing. Dude out of the way. Don't need clients on this one. So the only way we can tell whether we're moving or not is by whether or not we can actually see the shuttle outside. Which isn't very helpful if we can't see it. It's a better way we can do this. I know. Okay, so if we set this right in the middle of local space. Ignore that. Right, and then we find the proxy of this one. That one there. That one there. Okay, let's make sure that's visible. Not yet, Delta, no. That's what we wanted to break. It's hiding it. So obviously it's checking to see whether we're on the ship that we have the proxy for. And then it's hiding that proxy. We don't want it to hide the proxy, we want to be able to see it. Doesn't help that there's no sun. Hang on, let's set our graphics to potato mode a minute so that we can see everything. So I'm definitely not seeing the proxy. Hey Don, good to see you lurking. Right, so we're starting this off in 0, 0, 0, setting our own coordinates to there. So it should definitely be visible. Let's grab that. See if we can work out what's going on. So we should see the vector updating. Doesn't help that all the batteries are losing their cables. Weird, why is it? Oh, I see. It's also reporting the shuttle location, which doesn't help. So we'll do just branch that off a minute. So that is equal to 2, which is the Caravella's number. Then we'll do the debug. Right, and then those batteries are causing an issue. So I'm just going to get rid of these a minute. Try and cut down on the debug spam. Okay, so it doesn't think that we are on the right ship, so that doesn't help. Just make sure that these systems have the right cables. So what we're trying to do here is ascertain how much force is needed to move the ship. And then to do that, we need to actually see it moving. We have no point of reference out the window, so if we can move our proxy ship around, that will give us that insight. And the other thing I can do, actually, if we... Yeah, if we get the shuttle as well. And we stick that in front of us somewhere. Just see whether we can see that in a minute. Or is it behind us? Make sure we're not actually just zooming off into space and leaving it behind. Okay, so it probably thinks that we're on the Caravella. Sorry, on the Magellan. So I imagine that's going to respond to ID 0. Yeah, so it reckons we're on the Caravella there. Sorry, on the Magellan. And it's setting our location in a weird place because the Magellan's not there, so it's not having its location updated. So we need to make sure that we update the player controller with our actual ship, which means I suppose it'd be easier to do that from here. So we're updating the game instance there. Okay, so we're setting vessel ID 1, which I think should be 2. Okay, and then on the player controller, we need to do this matching ID. Set current vessel, same ID. Just so we know that we're using the right ship. And then on here, just make sure that we're setting the right ID, which is index 2, so making sure they match. Okay, and then that again needs to be 2. There we go. So I can see movement. We're trapped in the lift. Weird, actually. Why do these guys not have power? Frankie, I had to basically make my own world origin rebasing system. So it basically creates a series of cubes, and you are basically traversing through those cubes as the ship moves through space. Look, that's what I did wrong. I must have made a typo. Yeah, so as you move through space, you reach the edge of the cube, and it teleports you to the opposing edge of the cube, and it updates the galactic digit by 1. So essentially we can extend space infinitely, because all we're doing is flying from one side to a cube and back to the other side. And each one of those cubes represents 1 light year. So in terms of the physics simulation, the ship never gets more than half a light year in real physical distance from the world origin. And we're just using large world coordinates to handle that. But at the same time, with the new system we're making for tracking objects in space relevant to the ship, we're creating a proxy for those objects, which are positioned based on a much scaled down space environment. So those actually, as you move closer to an object, the proxy for that object is moving closer to the world origin. So the closer you get to something, the closer it's moving to the world origin. So it actually gets more accurate in terms of floating point the closer you get to it. At least that's how it's supposed to work. So this is interesting. It seems to be flipping its coordinates for the location of the ship, which is weird. So we're getting our matching ID. Okay. Okay, yeah, then we're getting an offset Right, so we're offsetting that relevant to that. So we should technically be on top of each other because the relevant transform should be basically 0. But what I don't quite follow is why it's suddenly changing. Let's grab that. Just make sure that that is consistent. I've never actually used Unity before, so I'm afraid that's a bit of a mystery to me. I'm sure the principles are the same though. Right, so the shuttle is there. Don't need that. So this one's at the world origin, so we should only be reporting the world origin. So that's reporting index 2. Shuttle's reporting index 1. Okay, so that's accurate. We're setting our current galactic coordinates there. And the current local coordinates should be stuck at 0. So we're getting the location of the actor in the world, which is what we're doing here. So we're setting that there. So essentially what we're doing is we're forcing it to be at those galactic coordinates at the very, very middle of the system. So right inside the star, essentially. So that's where we're setting the location of the physical actor. And then the proxy basically looks at whatever vessel you're not on, and then grabs that from the array. So we just need to make sure that we're setting those up properly. Okay, so for the proxy for the ship, so that's the bit that should be visible out the when you're seeing it from the shuttle. So our target vessel is 2, which is correct, and for the shuttle, which is there, again. So the proxy for the shuttle has a target vessel ID of 1. That was 2. Okay, so they are both correct. That's what we're reading there. I don't think we're Yeah, so that's just setting the mesh, which is fine. Okay, so all we're doing is running that looping event where we're taking our target vessel from game state and we're grabbing our current vessel from the player controller. So let's just force both of those to 2 a minute. I think something might be flipping that value somewhere. Right, so now we're seeing a consistent 0, 0, 0, which is what we want to see. We can see a shuttle around us, which is normal. Okay, and then the other proxy is on top of us, so all this Z fighting you can see here is good. This means that they are aligned, which is what we want to see. We want to see everything all aligned and on top of each other, which means that the event that we're running on proxy is obviously getting the wrong value from somewhere. Let's try that. Actually, that's just for testing purposes. Let's give both of them a hard set value. So I think they both default to 1. Then on that one, we'll set the current vessel to 2. Keep that one at 1. So we should see the Caravella on top of itself and the shuttle either in front or behind, depending on which way I got the X value. The reason we're using an index for the object is because at some point we're going to be spawning vessels on the fly arbitrarily. So, when we go into a star system and there might be one or more vessels there that we can board, we want to be able to add them arbitrarily to a list of valid targets that you can board. Similarly, if we spawn like an additional shuttle, because we'll have the ability to 3D print shuttles like this one, which is now in our way. Although that's interesting, it shouldn't be there. Why is it there? Because we're specifically telling it to be there. And that's in actual world units. So that's interesting. Like, is it not teleporting it? It might not actually have I was wondering whether it's got permission to do that. in terms of replication, but we're running, we're not running multiplayer, so it definitely should. So that's 50 meters. Let's do 75. I mean, that should be putting the shuttle quite far ahead of the ship. Assuming that this is the one that's actually being used. So we got, yeah, so flyable Caravella, that's going to 000, which is what we want. And flyable shuttle, which is going to there. Okay. And actually we need to change this as well, so that needs to go into 2, because option 1's the shuttle, so that should sort out our spawn, and then we need to just add our capsule half height to that so that we're not spawning in the floor. Yeah, I think once we start actually spawning stuff, then we'll get a better idea of how that's going to work. For now, this is fine. Although I am wondering where on earth, or why it's putting the shuttle in the middle there. Let's ignore that for now. Right, so now we've worked out where everything is. Let's grab our Caravella and then start adding impulse again, and then we'll see whether or not we're moving. Because we want to be able to add impulse at specific locations around the vessel to simulate the RCS. So that's not moving. Right, let's just make a test a minute. That's the engine one. Yeah. That'll do. Right, so we want to simulate physics. I think that's all fine on defaults. Make sure we're ticking. That's way bigger than I thought it would be. That's the wrong sphere. Ah, there we go. That should be the engine one. Yeah, that's the one we wanted. Hey Timmy, good to have you on stream. Right, no idea where that went. Of course, it's going to be it will have fallen through the ship because we don't have it on the right level, so we want it on deck 1 framework walls. Otherwise it's going to just fall through space the moment it spawns. Okay, still no idea where it ended up. Right, time for a test map, I reckon. Let's go to our props playground. Right, there we go. So that thing's getting impulse and zooming off into the distance. Great. That's what we wanted to see. So why don't we then replace that with the Caravella? Replace that with Caravella. Caravella. Sim. That's the sim one, isn't it? Yeah. Right, and then we'll put that at 0. Stick that up. Let's try 1,000. So this was the thing. It's like, how much force do we need to put into this thing to make it move? Yeah, definitely need more power. Seems an excessive amount of force. Oh no, there it goes. Right, so that's enough for us to lift it. Right, let's try turning that down a bit. Yeah, still enough to lift it. Yeah, not quite enough. So the question is it going to be pushing it in the direction of its own personal up vector, or is it using like world up? Because you kind of want it to be, if we're applying enough force to lift it and it's at an angle, it should be like scooting forwards. Yes, it is using gravity. So we're fighting against 1G at the moment. Hey Dricken, hopefully in the next couple of weeks. So we're working through bugs at the moment and trying to get as many bugs cleared off as we can, and then we'll be kind of confident in making it live. I'm trying to get this thing to the point where it's just scooting. In fact, if I it's an easier way. If we set that to 6, right, and then we just rotate it a bit, like it should scoot. It's not scooting. I want it to scoot. Interesting. Being rotated seems to nullify that force that we had. That's weird. So it's not rotated. Did I like delete a 0 or something by accident? Oh yeah, I must have done. Right, okay. Okay, so yeah, that's kind of what I didn't want to happen. It's rather than having the force local to the object pushing that way, it's pushing just straight up. So it's not, yeah, you'd expect it to behave like a helicopter and kind of scoot forwards. So I guess we need to, yeah, we're going to have to get the angle of the mesh. So if we get actor rotation, at some point the illusion, yeah. For now I just want to get it moving. So we need to work out from the mass of the object, and the mass is kind of arbitrary because you can actually define it there. So, oops, no, I don't want to do that. So it kind of comes up with its own mass based on the bounds of the object, We can override that if we want to, but we'll tweak the numbers, you know, once we get it actually working. So we want to get the actor rotation. We want to. It's going to be facing forward, so we want to. Yes, we want to break the rotator there. We want to add 90 degrees to the pitch. Then get forward vector and thrust in that direction. Yeah, they should be 0 to 360 those, so... Oh. Duh. It'd help if I actually gave it some forces, wouldn't it? Still going straight. Okay. Yeah, I'm not even sure what direction that was, to be fair. So that should be in world space. So I'm assuming that is also in world space. Perhaps I'm going about this wrong. Okay, so if we do the same thing, so we'll take the same amount of force, and that should be the local origin, so that should be our point, our center of mass. Does that? No, that flops to the ground. So let's make that 10 again. Yeah, it really doesn't want to go up. I'm assuming force and impulse. Aha. Okay, so right, that's more like it. That's what I want to see. I want to see it spinning wildly out of control, because that means that the force that's being applied is being applied at an angle. So obviously that's a different unit of measurement. Because right now it's basically balancing on a pinhead, because we're just thrusting from the mesh origin. Oh, thank you, C0. That's helpful. Okay, so the mesh is tilted forwards, and like the widget there is where the thrust is being applied. So we should be applying it that way. So I'm just wondering whether the I mean, it shouldn't be taking the physical shape of the mesh into account. It's almost like it's back end heavy. But what we want to do is I want to set up the actual RCS. So we kind of need 4 of these all operating at once to make it lift straight. Actually, that's talking of lifting straight, let's see what happens if we just try going straight up. Is it still back heavy? Yes, it is. Okay. So I imagine what's happening there is the thrust is not actually in the dead center of the mesh. Yeah, handbrake's on. And because I imagine if we look at our collisions, where are we? Collisions, collisions, collisions. If it's using the collision geometry as its shape, then there's a lot more of that going on at the back. I don't know how Unreal calculates that. I was under the impression it does it literally just on the mesh bounds, but given that it's back heavy, it probably isn't. But what we will do though is we will grab ourselves a socket and we will use this to position our first thrusters. Exactly, Ian, yeah, I think that's exactly what's happening. Right, so if we stick one there, so minus 3550, just minus 3545, yeah. Just want to keep the numbers non-decimal so that it makes it easier to remember. Set that to 0. Right, so the location of thruster 1 is there. And there. Right, so it should now be thrusting from that that location. Which it is. Okay. Mission accomplished. You wouldn't want to be on that, would you? Which means we can probably turn that down a bit now. Right. Now if we create another thruster and we put that opposite to this one, so this one's going to be the other side but in the same distance forward. It should now basically just flip straight up. Yeah. Okay. Working as intended. And then let's reduce the thrust of those right down. Okay. Now to keep this balanced, we're probably going to have to tweak the power of the rear RCS, probably to be a bit higher. Right, so we set that to 4350 and then 1535. Again at 0. Thinking actually we should probably daisy chain these so that we're not losing in any time. That one does need to be on the opposite side, doesn't it? Right, so it should go approximately up. Right, so that means then that we need to increase the power of these ones a little bit. Okay. Yeah, that's it's kind of doing a thing. Yeah, exactly. So that's absolutely why we're doing this. So the idea is that if you take damage on a particular thruster quadrant, then the ship is going to be like hard to handle. Right then, now let's turn off gravity for that mesh. Where are we? Oh no, wrong one. So turn off gravity. So it might actually fly off really quickly now. Yeah. What's the best way to do this? So what we could do, because we need to work out which thrusters are firing at any particular time, without taking too long to make that decision. So I guess really we need a boolean for each RCS thruster, each physical thruster within the RCS quads, because there's going to be probably half a dozen individual thrusters per segment, because obviously they need to face in different directions. So I'm thinking what's the best way of doing that? I guess, yeah, if each one has a boolean assigned to it, then every time we tick, we're working out are any of them firing. And if all of those booleans are false, then obviously nothing's firing. So for as long as the boolean remains true, the thruster will be outputting force. So we're basically using, I guess we're using the booleans like valves, like opening and closing a valve. Which means we're going to need numbered thrusters. I wonder if it's oh, there will be power, yeah. Just trying to work out the most computationally efficient way of doing this. I suppose individual booleans are probably the best way of doing it, because if we could do, just as a test, so without running a branch, oops, other way around. So basically, if firing is true, then we fire the thruster. Otherwise, we fire nothing. So we could do something like that, and then we could do timer by event. And if we set that to just a second, and then we can actually, we could just do this with pure logic, can't we? So we can get that. We can invert the value. So that's just going to keep flipping that boolean once per second, which means the thrusters are going to be on and off once per second. Let's take gravity back on for a minute. So it should kind of bounce. Yeah, so they're going to be firing on off per second. Okay. And then we shall, let's give it some actual visible thrusters so we can see what's happening. So that one is port forward. Then we have starboard forward. So those are the physical meshes. I mean, ideally, what we actually want to do is get the direction of the mesh, the way the mesh is facing. So we'll get the forward vector, and then we'll times that forward vector by a value. In fact, why don't we just literally do that? So if we rotate it 90 that way and 90 that way, eventually we'll make these into like actual thrusters, and we'll do them as something we can just apply to the ship. And then let's make them red. Super high detailed RCS thruster model. Okay, and let's get rid of that a minute. Can't remember why that was there, but we don't need it. Right, so we'll do this thruster by thruster. So, starting with port forward, we'll get actually, we could actually use this. So if we get relative location, and then get relative rotation, and then get forward vector. Then what we can do, so the force would be that multiplied by our float, which in this case will be that. So that's our force. Sorry, no, that's our force. And then our location would be the location of the physical mesh. So we're actually using the mesh itself to generate the thrust, because ultimately that's how we want to be doing this. And then I guess that needs to go into there. This is nice and messy already. And I guess at the same time, we want to actually see that the thruster is doing something. So we will turn that off. So if that's true, it will be firing. Otherwise, it will not be. Yeah, I think that should do it. If we just do this one thruster for a minute and see what effect that has. It's going to fire down at the moment, so just need to make sure that's actually facing the other way. So that should be minus 90. Oh, may as well do those the same actually. Minus 90. Right then. And of course, they're not firing up there, are they? They're firing down there. Alright, so we should be seeing that one firing. Okay, so it's, you can see it turning on and off. That's a start. Let's try turning it up a bit. And we'll make sure that all of them are invisible to begin with. And we'll try just turning that up. Let's not complicate it too much. Oh, Sophie, thank you. As always, you are awesome. Oh, yeah, I've got the direction flipped. It's thrusting down, not up. But it is thrusting. Right, okay, hang on then, let's flip the rotation. So these guys obviously need to be plus 90, not minus then. Yeah, there we go. It's working. Okay, let's turn that back down again, I think. Yeah, okay, that's working. So we just need to duplicate that 4 times for t'other thrusters. Getting these guys balanced is going to be fun. So just out of interest, let's add these in the right place, so they're all equally balanced. So that one was there. And there. And we'll put them in the middle. I'll extend the mesh so we can actually see them. Or will I? As long as they're all the same, actually, that shouldn't matter too much. Right, so if that one's there, and that one will also be there, and -1327. Right, that's those two in the right place, and then these ones are both that far away from the front. 1535 -1535, and both of them should be -170. Okay, so they are now balanced in terms of being locally balanced. Okay, so what I'll do is on our proxy mesh here, I will remove collision and add a single box around it. Just to see how that affects our balance. That's definitely updated the mass. Yeah. That's better. So the fact it's pitching down is to be expected because we added a bit more power to the rear thrusters. Or actually, or did we? Because I think we just copy pasted it, didn't we? Yeah, well, we will update and tweak and refine all of that. This is just about making sure that we have RCS thrusters that actually work. Which we kind of do. Alright, so I think we're applying the same force with all of them. Yeah. Okay. Right, so rather than turning them on and off, let's just we'll have them firing for 3 seconds, and then we will turn them off. Okay, that seems relatively stable. I think it's still pitching nose down a bit. So ultimately, it is the physics volume that it's using here. I will see whether we can define a proper center of mass for it and have it not use that. Not sure we even have controls for that on the mesh itself. No. So we'll need to add our own physics collision for this to make sure that it's properly balanced. Right, so let us do another experiment a minute. Guess what we want to do is let's make sure it's not colliding with anything already. No, it's fine. We only turn on the front ones for 3 seconds and then off. No, even better actually. We turn on the 2 port ones and see if we can make it smoothly barrel roll. So we need 4 of these now. So I'm wondering whether or not it might be better to do this in an array. So we'll have an array of booleans and then loop it for these, or whether or not this is actually brute forcing it but doing it quicker. So we've got port forward, starboard forward, port aft. We don't have. Oh, okay. That's annoying. Starboard aft. So port forward, starboard forward, port aft, starboard aft. Right, so we can now control them individually. So we want starboard forward, and we also want starboard aft. Oh, sorry, not port aft, rather. And these should all be false by default. Yep. Right, so it should roll. Did you see it? Did it roll? Okay. Okay. Now, I think the reason it kind of crabbed sideways a bit is because the RCS thrusters are not equally centralized, but also because they're downward, they're not on the mid plane, so we'd need a second set up there, the same distance above the mid plane, in order to have a smooth rotation. Yeah, we need an opposing force, don't we? So let's add those. Yeah. Again, once we actually start, honing in on the actual physics, then obviously things like mass, inertia, and everything else will need to come into play. For large ships like the Magellan, we don't want them to be able to pivot and dive like a fighter. They need to be slow and lumbering. Right, so what we need to do now is rename these. So that's port forward down, starboard forward down, port aft down, starboard aft down, and then the up version, which would be 170 minus 90. Okay, that one, that's the up version. 170 minus 90. For right, and I guess this is where it starts to get heavy, in that we're now having to quadruple this. See, a lot of this is macroable, isn't it? So let's do that. Yeah, so we take that and that, not that, collapse that to a macro. Yes, easily done. Just collapse it to a macro just like that. Just like that. Right, and we don't need all of that. Bit neater. Of course, these also need to be renamed. Yeah, so the main thrusters, yeah, absolutely. And of course, because the main thrusters are in triplicate on each one, there's actually 6 per quad, per engine pod even. So we need to do this for every single thing that provides thrust. So if one of these engines is out, then obviously the others need to compensate. Working out how much to compensate by is going to be fun. Port forward down, starboard forward down, port aft down, port aft down, starboard aft down. It's going to just do a quick test, make sure it still works. Yep, still works. So this is where it's it potentially gets quite unwieldy, because obviously the more thrusters we have, the more we're having to do this. So then we go port forward up, starboard forward up, port aft up, starboard aft up, and then we need the up versions of those. So port forward up, starboard forward up, yeah, basically, well, so they won't have them firing 100% capacity. So if we need to have that room for maneuver a little bit. So if one fails, then the others need to be able to kick in, or kick up rather, to meet the demand. We also need to make sure that, like how they do on the SpaceX Dragon, none of the thrusters are pointing along any of the actual XYZ axes. They're all offset to some degree, so that there's redundancy there. So, like, if the forward is pointing, say, more 45 degrees to the side, then it can function both as a left and right thruster as well as a forward and back thruster. So we'll do something similar along those lines. So if you suddenly need, if you lose your actual left and right thrusters, then you can fire the forward and the rear, and it will still shift you sideways a bit. There's probably some math to make the most efficient version of that. Right, so we want port forward up. Why are you doing that? And then hang on, no, we don't want that one, do we? We want the starboard forward up. And then the starboard aft up. Right, so that should be opposing thrusters. Yeah, there we go. I would dare to say that that is absolutely stable. We have perfect balanced thrust. Yeah, that doesn't seem to be drifting at all. Okay. Right, let's see if we can stop it from rotating. Because technically, if we apply the inverse of that, we should cancel out exactly all of the thrust. So we'll do... I guess we need the exact opposite thrusters, don't we? So if we wait... let's say 5 seconds. Right, so port... this is where it gets confusing. So port forward down would become starboard forward up. Oh, actually, we can... actually. No, because it's the opposite of what we got, isn't it? So port forward down, become port forward up. And then port aft down would be port aft up. And then starboard forward up becomes starboard forward down. And then starboard aft up will be starboard aft down. And we'll just make sure that we're not delaying that. So we start our spin. Ah, almost. Yeah, there are many little tips and tricks like that which just make your life easier. Yeah, I mean, we could try firing them just a little bit less. That is surprising though. I would expect I would expect the equal amount of thrust in the opposite direction to result in 0. So I'm surprised that it didn't. Talking of things that I didn't know, like I didn't know you could move pins like that by holding down control. I would always break it and remake them. But yeah, being able to do that, I learned that like a week ago. I'm always learning new stuff. I'm gonna make this delay for longer so we can actually see it from the loading screen cam. Oh, so close. Yeah, I love that video, Delta. It's really good. And yeah, we want lots of that. I wonder if it is the same every time. No, it's not the same every time. Huh. Okay, so that's oh, interesting. That's like spot on. Yes, AJ, definitely. So, yeah, so one of the things that we need to do is we need to have a flight assist mode. So by default, the ship's going to be fully Newtonian. So we're using actual physics for the thrusters, and the ship will just spin off unless you apply opposing thrust. But for people that don't want that, we need some kind of flight assist mode. So we'll probably do something along the lines of angular damping, which should theoretically, yeah, do that. So it stops it. So what we'll do is for our flight assist, we will apply angular damping to movement. So as soon as you take your hands off the controls, the ship will just slowly come to a stop of its own accord. So it's not a flight assist that will allow you to fly the ship like an airplane, but it will null out all of the rotations, so if you're panicking and the ship's all out of control, all you need to do is just take your hands off the controls and it will actually come to a stop. That's probably the best we can do in terms of a flight assist mode. Yeah, I would have thought so, AJ. We'll just have them on mildly. There isn't actually, Sam. That's not a bad shout. Yeah, so that came to a rest quite happily. Right, yeah, let's add that delay, because you're right, that could mess up some stuff. Okay. And at the same time, we shall remove the delay from there. Obviously, having a damping on it will also mess up. It will mess up how we do the inverse thrust. Let's just see whether that stops, out of interest. Okay. So if we do the exact opposite then. Ah, okay, yeah, so that is stopping it perfectly. Right, let's turn down the force a little bit. Maybe half the force. Where are we spawning at? Yeah, let's move that over there so we can see it a bit better. Okay, I reckon that needs to go down just a little bit more, maybe 3 million, whatever that is. That million? 300,000? Yeah. I don't actually know what unit that is expressed in. It's 300,000 somethings. Which is obviously too low. So the interesting thing with this is going to be like having the ship fire the right thrusters in order to face a certain direction or to target a certain object, because we need to work out first of all which direction we need to turn in, and then which thrusters we need to fire in order to face that object. So that's going to be an interesting challenge. Yeah. I'll be interested to see whether it does that a second time. Yeah, because when we build the autopilot into this, right now the autopilot's relying on the 6DOF plugin, because that does facing of the pawn. But this isn't a pawn that's being controlled. This is just a static mesh that we're applying thrust to. So yeah, it's going to fundamentally change how we approach ship flight, which is why the sublight update is going to be quite involved, because we're suddenly turning on real physics for the ships. Like the fact they will just spin forever unless you do something about it. So another experiment we can do actually. If we enable input, right, and we do numpad 7. So do numpad 7 for that. Get rid of them. And then we do numpad 9. Just realised we also need to turn them off. Yeah, just something kind of quick and dirty like this. We're using the galactic plane. Ah, that works. Okay, so using the keyboard, I can now fire the thrusters. Seems to be working nicely. So that gives us a roll control. We should be able to cancel that out, like so. Right, okay. So for our next trick, do numpad 5. So I'm going to try and do pitch now. So numpad 5. So this is going to be, so the forward ones. So what are we doing? So we're doing forward, down. Support forward, down. And then starboard forward, down. And then we want port aft up. Starboard aft up. Right, that should give us pitch up control. Interestingly, we don't have much in the way of control authority there. Oh no, so the damper would simply just stop rotation. It won't try to align the ship with anything. It will literally just stop rotating. Yeah, you'd think. Yeah, you'd think though, with pitching, because the thrusters are further from the center of mass, then the pivot forces would be higher, because you've got more leverage than rolling. Right, so then we need the opposite of this for pitching down. And I think what we'll do as well is we'll need to set our force. So let's try doubling that to 8 maybe. And then on these ones, obviously we'll have to set that as well. So we'll have to tweak the force numbers depending on the maneuver that we're making, just to complicate things slightly. Right, so for the other way, so we want port forward up, and then starboard forward up, and then port aft down, and then starboard aft down. Let's just try that a sec. Okay, so that gives us up and down. We've still got, yeah, we've got a lot of control authority for rolling, but not much in the way of pitching. Okay. There we go. It's interesting actually, like a certain speed will auto damp to 0. See if I can stop it doing that, because we want it to be able to drift slowly, not stop. So the question is, can I correct? Yeah. It does feel inherently controllable, so that's good. Given that this is full Newtonian physics, it's not difficult to control, so that's good. Okay. But there must be some kind of like internal damping going on. I'm wondering whether it's one of these. Aha. Perhaps it's that. No, it wasn't that. That's still stopping too much. Perhaps it's actually sleeping, which would make sense. Oop. Of course, we have no up or down yet, so nothing we can do about flying off into space. Okay, let's zero these out as well. Okay, I think I'm just going to have to go on a bit of an investigation of this, figure out why it stops moving with micro movements. I'm assuming that's some kind of an optimization that I'm hitting up against. I don't think it's that. I mean, we can use that to limit our spin, which is nice. Ah, that was it. It was the sleep family. So setting it to custom means that we're able to have micro movements. There we go, that's better. That's it. We've got more precise control over it now, and we can do micro movements. Great. Right, so it should be much harder to stabilize that now. So if I set it on a spin, right, it should be more difficult to get that stable. So this is where we need forward and back thrusting now, so let's try that. Okay. I do have another keyboard which is inherently a lot more quieter than this one. I just haven't got around to plugging it in yet. This one's very clacky. Right. So I won't add all of the engines because there's like 24 of them. So yes, yeah. So all of the shift movement, left, right, up, down, backwards, and forwards, is all going to be handled by directional RCS thrusters. So we need, at the very least, one up, one down, one forward, one back, one left, and one right. Well, one right, left will be on this side. Yeah, so we need RCS thrusters facing all of the directions. Yeah, the tinkling shrimp tank. Alright, so if we grab that on there. Think of something to call it. We start with the port side, actually. Fortunately, I have thought ahead with this, and the engines are actually directly aligned with the center of mass, so I can actually just position those in a balanced manner. So if we were to say 1488 that way, so 1500, no, 1450, 1480, 1490. That's weird, actually. That should... Hang on, that doesn't make a lot of sense. So the engines are aligned directly to the middle of the ship. Like they are literally angled at the origin point. So why are those two numbers different? I am confused. Because that's... Oh. No, it's alright. No, I'm not going insane. It's because it's not a 45-degree angle. That's why. So as much as they are aligned with the middle, as you can see, it's not a perfect 45. Therefore, those numbers will be different. It's alright. Don't panic. Disaster averted. So if we say 1900 for that one. Right, and then direction-wise, that's already going in the right direction. Make sure they're perfectly balanced. So that's main, starboard, forward, up. I should have named them the other way around, to be honest, but we're stuck with it for the time being. So it's main, starboard, forward, up. And then we've got main, port, forward, up. And that just needs to have negative on that axis. Okay, and then we've got main, starboard, forward, down, which just needs negative on that axis. So in that regard, previous me was useful. And then that should have been port, which means that one needs to be minus. Have a good one, CSI. Right, so there's 4 engines there. Oh, I've got these the wrong way around. So port goes that side, starboard goes the other side, because that's the front of the ship. Right, so this is main, port, aft, up, and that needs to go there. And then from there we can do the other ones. So to rotate that 180. Right, so main, port, aft, up. Main, port, starboard, up. And that needs to go on the other side. Port, starboard, main, port, I won't get myself confused now. Main, starboard, aft, down, which means that one was main, starboard, aft, up. Main starboard aft down, main starboard aft up, main port aft up. Main port aft down. Okay. Right, so that's all 8 thrusters. So all that needs to be done now is we can add them to the numpad just so we can test them. Save all that a minute. Oh, there will be 3 for sure. Right now I'm only using 1 just for testing purposes because as you're about to see, the amount of logic required to manage all these individual thrusters is going to be huge, because all of them need code and the ability to actually add thrust. Given how many there are on the ship, I mean, this is going to come down to here somewhere. So I need a better way of doing this. I think adding them all to an array maybe, and just looping the array is probably the best way of doing it. If I do it as a struct, actually, because then we can have a reference to the actor, and then a reference to whether it's firing or not. I was wondering whether it'd be better to do that now. Yeah, it would be better to do that now. RCS mapping. Ooh, wow. Mappings. So that should just be a static mesh component. Yeah. Yeah. Ultimately, you're right. We need a processor for taking raw input and turning that into thruster firings. So we need to have a mapping against, you know, which input is relevant to which thrusters. And I suppose we're better off just doing that now. Now that it's a bit more complicated. So we got the thruster reference there. Which is a static mesh component object reference. Yeah, and then we just need a simple boolean for whether or not it's currently firing. I watched a long ranty video once on the correct way of naming variables, and specifically booleans. Like, putting a question mark on it is kind of, it's implied because it's a boolean, but I like putting question marks on them because it helps me visualize their purpose in my head. So yeah, hate me all you want, I'm going to put question marks on them. Yeah, and in Unreal parlance, you put a lowercase b on it to indicate that it's a boolean, at least in the C++ world. Yeah, that's fair enough. Right, so instead of this horrendous long list that we're growing, what we'll do instead is we shall take our thruster array, which is not an array, and we will simply do a for each on there. Now my main concern with looping an array is that it's because we're having to loop through what might be 20, 30 entries. The thrusters are not going to be firing simultaneously enough for the control, but we'll see. See, how much cleaner is that? Right, and then all we need to do is actually set them up in the array. So this is going to be awkward, isn't it? I'm not going to be able to get a reference to that. So setting up the array obviously is going to be a required task, and then we need to know which array ID corresponds to which direction, because obviously when we press our controls, what we're doing is we're actually going to set we're going to get a reference to our index, and then we're going to go set members, specifically whether or not it's firing. So this avoids the need to be making separate booleans for every single thruster, but there is some precursor work in actually setting those up. Oh, that's a good point, actually, Illusion. Yes, you are quite correct. Yeah, that'll be useful. So yeah, we'll set force at the same time. So yeah, so instead of that, we're going to have to do that 4 times. And then we'll just be obviously just looping that continuously. And yeah, we'll stick force on there as an input as well, actually. And then we don't need that anymore. Stick that on the macro. Cleans that up nicely. Yeah, that's kind of what I'm about to do. So if we set up an enum for RCS inputs, obviously when we actually implement this properly, we'll be using Unreal's native enhanced input system, so we'll be mapping them against that anyway. But we might actually also compare it against this just to make sure we have some logic kind of defining directions. So I'm going to put them in separately, because each one of these is going to have a corresponding number of thrusters that are used. In fact, let's do main forward, main aft. That covers the main engines. Then we've got RCS forward, RCS aft, and then because we're going to have up and down as well, of course. Pitch up, pitch down, your left, your right, roll left, roll right. Generally we do pitch, roll, yaw, so we'll keep them in the right order, and we also need slide left and slide right. Right, so forward, back on the main engines, RCS forward, back, RCS up, down, RCS left, right. Then we've got pitch up, pitch down, roll left, roll right, yaw. Right, that should be all of the different permutations of inputs. Exactly, quick as me, yeah. It's Kerbal without the orbital mechanics. See you, Danger Mouse. Have a good one. Right. That should be all of it. I can't think of anything there. We don't have main engines for anything other than forward and backwards, so that should be it all. So if we stick that on there, so enum RCS. And that's not an array. Actually, we want to set that, don't we? Right, so for all of these here, we are going to set our input mapping just thinking about handling the released. I suppose released doesn't matter quite so much, because if we use the input mapping for a gate, So what we got? So 7. So that was roll left. So roll left. 8. Sorry, no, 9 was roll right. Roll right. 5 was pitch up. 8 was pitch down. Where is it? There. Right, then if we do a custom event on here. Actually, we probably don't even need that variable because hang on, brain thinking. Yeah, so if we do I might make this a function or a macro. We'll see. Alright, so we need to know what our input is. So that's going to be our enum RCS inputs. And then we want to know whether it's pressed or released. So a simple pressed would do for that. Right, so rather than doing that, instead we would do that. So we're basically we're defining which input we're pressing and whether or not we're pressing it, and then on here we would do a switch on that, and then depending on which one we're dealing with, we would then set up, well, rather we take our thruster array and set the values on that array accordingly, so that on the next tick we are turning thrusters on and off as required. That's going to get huge, so I'm thinking, yeah, I'm thinking macro rather than event. It doesn't need to hold any variables, so yeah, macro should be fine. Alright, fine. If you don't, it won't collapse because there's an event in it, so let's just make a macro. Which it won't let me do because that exists. Yeah. In terms of, we're doing it so that the ship just places itself in a stable orbit when you come out of FTL. We don't want the game to be like too Kerbal-like in terms of the orbital mechanics, because that's not the game we're making. I mean, we want a game where you're exploring space and unlocking the mysteries of space and, you know, flying down to planets and exploring and all that stuff. If we add orbital mechanics as a requirement for that, then essentially we're remaking Kerbal, and we don't want to remake Kerbal. Kerbal is perfectly good as it is. Yeah, I mean, we will have fully Newtonian physics in local space around space stations and things. So, you know, the combat will be Newtonian, flying around objects in space will be Newtonian. So, your ship will drift and roll, forever unless you apply an opposing force, but not to the point where you'll have decaying orbits and the need to accelerate to escape velocities to get out of an orbit, because it's just beyond the scope of what it is we're making. No, we're still in time. It's only 20 past 11 here in the UK. We've got 40 minutes yet. Okay, so before we can set up our thruster mapping to our inputs, all good. We need to set up what those mappings actually are in terms of our thruster array. So we need to assign IDs to all of those. Yeah, I was going to say we could maybe do it there, but we can't because we need to set it as an array. Okay, right, let's just do this again a minute. So, right, so H was pitched down, so manage input. Oh, no, pitch down. So this is still going to require a lot in the way of node space to put all the inputs in there, but I think that's probably the lesser of two evils when it comes to node bloat. That's a pitch up, pitch down, and then 7 was roll left. And 9 was roll right. Yeah, so we're going to have a whole bunch of these. And again, we will replace these with like input actions. So, these are all the enhanced input things. So we'll have the ship ones on here somewhere. Oh, like that one. So we'll have the actual enhanced input things that we'll drive these with, but for now we'll just use direct mapping just for testing. Right, so that means then on begin play we enable input, and then we need to set up our thruster array. So just for sanity's sake, we will clear the array first, and then we will add I suppose we can just do make array there, can't we? But if we're doing that, we don't even need that. So yeah, this is going to be fairly bulbous in terms of the amount of nodes as well, but kind of unavoidable. So we don't need to worry about firing or force. We just need to worry about which thruster is assigned to which array element, because we're going to be pulling those out by their IDs. So we just need to consistently know which array element corresponds to which thruster, of which there are many. So if we try and do these in order, we'll start with the main engines first, I guess. There's probably a better way of doing this, but I just wonder whether I suppose I could use a data table, but then no, I can't, because we need references to the actual components that are dotted around the mesh. Okay, so we want main. Make life a bit easier for ourselves. So main port up. Yeah, so main port forward up. Let's just duplicate this slot 8 times. So this will be all for the main engines. So main port forward up. Main port forward down. And then we've got starboard forward up. Oops. Starboard forward up and starboard forward down. Okay. The opportunity for human error in this is huge. And that's why I don't like doing things like this, because it's very, very easy to just mess something up because you get confused with yourself. So we want port aft up, port aft up, and then port aft down. Narrow it down a bit more. So port aft up, port aft down, and then starboard aft up, starboard aft down. And then we add a bazillion more. Yeah, it's one of those things in game dev where you end up just having to do the grunt work. I mean, you only have to do it once, to be fair. Delete all those unwanted variables in a minute. Right, so if we do... So just do forward. So we want port forward up, and then port forward down, and then starboard forward up, starboard forward down. Okay. Anyone? Port aft up. Port aft down. Starboard aft up. Starboard aft down. Right, so I think those are all the ones that we've done so far. Right, so now we know which thrusters correspond to which array element. I'll use those in a minute. Well, if we have time, we'll be using those. Right, so that sets up our array. So all of this is no longer needed. Instead, what we're going to do is we're going to go into our macro here. I think for just for ease of reference, I'm going to pop that there, just so we can remind ourselves which one goes where. Okay, so main forward, that was, so we're going to require 4 of them here, so we need that one, so it was main forward, hang on, because we need the opposite of this, don't we? So if we're firing, so if our input is forward, we need to fire the aft engines. So we actually want the aft ones. So that's U. So that's 4, 5, 6, and 7. Yeah. Can we? Oh, I was hoping we would be able to group those references. Although I was wondering whether we could loop a portion of the array, because that would be handy. I don't think we can, although we can pull the index. Yeah, we can do that, can't we? So we know we're going from reference 4 to reference 7. So then all we need to do is get those references, and we're setting the same thrust values anyway, which was yeah, and whether or not it's firing is going to be based on that var boolean. Right, so that keeps that tidy. So if we're going aft, then we need to fire the forward engines, which is 0 through 3, I think. 1, 2, 3, 4. Yeah. 0 through 3. Right, so that should set those values for those individual thrusters in that grouping. Obviously that only works if they're sequential in the array. If we're firing like 2 from there and 2 for down there, then we won't be able to do it like this. We'll have to do it slightly more manually. Let's add an input mapping for that. So we want numplad plus and then numplad minus. Right, so that's main forward. So we want to go forwards. And main aft. No, main aft. So let's get rid of all of that now, and all of that. What was this? Oh, that was me messing about, so I don't need that. Okay. So there's our begin play stuff, there's our tick stuff, and these are our control mappings. Look how much tidier that is already. So after all that messing about, we should just go forward and backwards. Let's try it. So forwards, huzzah. And it seems to be stable as well. And then we should be able to reverse thrust. Okay, that's working surprisingly well. We don't seem to have any real issues with the fact that we're looping that array on tick. I mean, we can probably reduce the tick rate on that a little bit. There it goes, flying off into the distance. That would be quite funny, Madden. It reminds me of that scene in Star Trek Next Gen when you've got Data and Wesley Crusher pulling out all the chips, those isolinear chips. That would be quite funny. You're right. Although you say that, one of the things we'll have is we'll have data cables going to the individual RCS thrusters. So the server hardware in the server room will be sending signals down data cables to fire the RCS thrusters. So if those data cables are severed, then the RCS thrusters will not fire. They may be fully functional and fully capable of firing, but the signal's not getting through to them. So you could literally board a vessel, cut the data cables, and then leave it stranded in space. It's entirely doable. Right, let's do our pitch inputs. Okay, so I guess for this one we'll just have to do it with a sequence. I tend to get quite OCD over nodes. You may have noticed. I like nice tidy nodes. Right, so we're pitching up, therefore we need, so port forward down, which is 9, and starboard forward down, which is 11. So we want 9 and 11. So we're pitching up. So then we need port aft up, which is 12, port and starboard aft up, which is 14. So 12 and 14. I'll have to maybe find a less insane way of mapping these. Let's just check that actually works a minute. Yep, that works. Bump. Okay, and then we need to do the opposite of that. Pitch down. Actually, we'll to keep it sane, we'll collapse these once we're done with them. So that would be main forward. Main aft. Just stops it getting a bit out of hand. Right, so the opposite of these then. So we're now pitching down, which means the front ones need to fire up. So port forward up is 8, starboard forward up is 10. So that's 8 and 10. And I assume the next ones are 11 and 13. And then the back ones need to fire down. So we want port aft down, which is 13, starboard aft down, which is 15. Okay, 13, 15. Okay, let's just test that. If you mean like a flight assist mode, so you let go of the controller and it will gradually stop spinning, then yes, there will be an option to enable that. That aside, there will be a maximum velocity. Not sure what you mean, Madman. The issue we have with indexing which thruster to fire is that obviously they are child components of this actor, so we need to reference those child components specifically, and the only way we can get a reference to them is by literally dragging them into the graph and referencing them directly. So that builds our array. Yeah, I mean we could make another struct maybe that includes an enum for each one, maybe. Yeah. I mean, this is the most straightforward way of doing it, because we're just, as long as we know which index we're pulling a reference to, we're all right. It's just the initial setup is a bit of a headache. I don't think you can. I mean, because this is our array, and I already attempted to add those. I mean, can you drag them over? I mean, no, because as soon as you highlight one, obviously you lose the thing you had highlighted. If you could drag them across, that would be nice. What if you can copy a reference? Actually, can you do that? No. So if you could copy the reference to it and then paste in the reference, that would be nice. But you can't do that either. I mean, you can copy a reference to something in the... I don't think it has a dropper. No, there's no dropper on it. Unless there's one up here I can find. No. I mean, it would be nice if we could directly reference a child component. Obviously, it's not listing any, which is weird because the data type is static mesh component, and these are all static mesh components. So you'd think that it would know that they were there, but I can't think of any way to reference these components directly manually in this array. Yeah, if anyone figures out how to do that, please let me know. Right, so for rolling left, we need we're probably going that way, so we want port up, aft up. So port forward up, which is 8, and port aft up, which is 12. So 8 and 12. 8 and 12. And then on the starboard side, So rolling left, so the starboard side is the down. So we want port forward down, which is 9, and then port aft down, which is 13. So 9 and 13. Right, so that should be the ability to roll left. Did I not just hook that up? RCS roll left. Do we have a... Yep, 7. RCS roll left. RCS roll left. Eight, 12, 9, 13. So up and down works, forward and back works, 7 is not doing anything. Okay, so the input's working. Okay. Yeah, makes sense. Weird. Why is it not doing anything? What? So we know it's firing this pin. What am I missing? I mean, they work. Hang on, just to see whether it's the fact I copied it. I might have broke it. Let's just try. Is it a bug? Oh, it's none of the thrusters. Yeah, so it will fire those ones. So it's not that. That would be nice, yeah. I just do print strings on everything. So we know that the mapping is correct because we've got other thrusters that are, we've got other inputs rather that are firing those same thrusters. So that makes no sense. Hang on, let's stick the roll right on there and see whether or not that does anything. Neither roll left or roll right are doing anything. Let's just try the pitch controls a minute, see whether same thing's happening with them. RCS roll left. I suppose we'll do roll right while we're at it. Oh, I never use breakpoints. I just I just like the spam, I guess. Right, pitch up, pitch down, roll left, roll. So yeah, so roll right then. We want. So we're rolling to the right. So port side needs to fire down. So port forward down is 9. Port aft down is 13, so we want 9 and 13. Rolling to the right, so the starboard side has to fire up, so we want starboard forward up, which is 10, and starboard aft up, which is 14. So 10 and 14. Try that a minute. Okay, so roll right works. I think it definitely needs a rotation cap. I assume that's just going to get faster and faster until it hits the nozzle velocity. Hang on. Something was firing then. Yeah, I think you're right, actually. I think we're hang on. Yeah, I think we are actually firing on the same side, which is, yeah, look, that's what's happening. So effectively nothing's happening. I did mention human error earlier, didn't I? So which one's the wrong? So we're rolling right, sorry, rolling left. So we want the port side up. So it's port forward up would be 10, port aft up would be 12. So yeah, so we want 10 and 12. Yeah, that should be it. There we go. Yeah. Still wrong. In an amusing way. It's interesting that that's as stable as it is, to be honest. I mean, it's slightly wonky, but managing it. Right, roll left. Just going to sanity check myself. So we're rolling left. Yes, we're firing up. So starboard forward up 10. Aft port up. Sorry, port aft up 12. Port forward. Port forward up. Yeah. And aft forward up. So that's 8 and 12. Right, then the other side would be down. So it would be starboard forward down, which is 9. And then starboard aft down, which is 15. Yeah. I've still got it wrong somewhere. Hang on, which one's wrong? So, right, so the starboard side is correct. Thank you, Firstus. So which one have I got wrong? So it's the first one. The first one is port forward up. Port forward up. Yeah. I've got myself completely confused now. Hang on, so yeah, so port down, starboard up. So port forward down is 9. Aft, port aft down is 13. So hang on though, we're rolling left, so we're firing, we need to fire up on the port side, and we need to fire down on the starboard side. So, because this is the direction of the thruster, isn't it? Have I got them in the right place? No, I must have. Yeah, you're right. A spreadsheet would help. You'd think that I'd be able to just like see it, but it's midnight and my brain's just gone. Yeah, so on the left we're pushing the ship down, which means we need to fire up. So port forward up 8, and then port aft up, which is 13. So it should be 8 and 13, right? Okay. And on the starboard side, we're pushing up, so we're firing down. So on the starboard side, it's starboard forward down, which is 11, and then starboard aft down, which is 15. So it should be 11 and 15. Sure, that's right. The starboard side's correct. Did I? How am I getting this wrong? Port forward up is 8. Port forward up. Yeah. So port forward up, that's that one. And then port forward down is that one. Yeah, so that's right. Port left, forward, up, because we're firing up to move the ship down. So 8 is definitely 8. Yeah, it has to be 8. And then starboard, sorry, port, aft, up is 12. Because we're on the port side, aft, we're firing up to push the ship down, so that should be 12. So 8 and 12. There we go. That was as clear as mud. Okay, so roll check, pitch check, and thrust check. Ship's upside down. Wonder why it was doing the opposite controls. Okay, well, that's definitely flyable. It's like flying a remote control Starship. Uh-oh. Floor. Floor. Ah. Ah. Oh, saved it. Saved it. Yeah, we're good. maybe. Oh no. Another happy landing. So yeah, that all seems to be working splendidly. Now tomorrow is a Monday, so I only stream Sundays, Wednesdays and Fridays. I don't know why the frame rate suddenly tanked, that's weird. Yeah, CPU thread has gone a bit weird for some reason. I don't know what's going on there. Is that something we're doing with the array? It's really nice actually to actually see the ship actually doing something physical for a change, like seeing the engines fire and the RCS thrusters firing. It's nice just to see it come alive. That's what we definitely want to see, you know, as the ships flesh out and get better. We want to see them just doing stuff all over. Lights, flashing lights and thrusters and all sorts. So the concern there actually is that we were starting to tank FPS wise. So that array should never be growing. Let's get rid of these unneeded pins so that we're not looping more than we need to. So we're only setting the array on begin play. So once that's done, that should never be touched again. And then all we're doing here is managing the visibility of the individual thrusters, just adding some force which goes away. I suppose we could see we're constantly applying 0 force, and I'm just wondering whether or not branching that might be a bit more performant. I mean, branches tend not to be, but I try and avoid using them if I can, but maybe that will help a bit. I'll have to profile performance on that. Yeah, definitely. So when it comes to the shuttle bay, yeah, it's going to have a lot of markings on the floor. It's going to have a lot of... Oh, cat just caught itself in a laptop. Yeah, we want floor markings, we want parking bays, we want the shuttle bay to look like it's an active environment where it's actually properly managing shuttle operations. So I'm just messing about with this for a minute, because the concern was that frame rate tanked, and I'm worried that something was happening on tick that was causing us an issue? I mean, it might be nothing to do with this, but check it just in case. Oops. No, we've hit the ground. Definitely need that up and down RCS control. Oh, it doesn't seem to be getting any heavier on the CPU thread that I can see. Perhaps that was just a one-off glitch. Yeah, it's you know, now that we've got this set up for this ship, we can port this system to every ship really easily, and that was the whole point of having the Caravella as a test vessel, because we can then use it as a test bed for every ship in the game. Okay. Well, we definitely made some progress there. It's yeah, like I said, it's lovely to see the ships like start to come alive, and you know, once we put proper thruster graphics on them and, you know, proper thruster effects, it will look a lot more organic. Yeah, for sure. And it gives you an idea of what it's going to start to look like once we have like multiple vessels in space and stations that you can fly around, and, you know, other ships coming in and out of stations. It's going to look very, very cool. And on that happy note, I think we will leave it there. So thanks once again, everyone, for sticking with us for what was a trial and error stream, but we got there in the end. And I shall see you all on Wednesday for more Magellan class stuff. And to be honest, we could try doing the same again, actually. Maybe bolt some thrusters onto the Magellan and see how she performs. Right, have a good week, everyone, and I shall see you on Wednesday. Bye for now.